This video from Plessey Semiconductors will show you how to set up the Seatpad for non-contact measurement of ECG. We have here the PS25006 interface box, and you can see the 6 connectors there which go to the 6 sensors in the Seatpad, and this is running through the standard PS25000 box. We have in here the low pass filter switched in, a gain of ×10, and the notch filter also switched in. The 6 input box, we are currently using sensors 2 and 5, and we have the DRL gain setting at around 80%, but we'll show you how to set that up now. So for setup, the best thing to do is to first of all select the individual channels A and B, and just for now we're going to hide the differential. We're going to remove all of the filter settings, so you can see the traces have disappeared from the screen. We'll set the time base to 0.1, and we'll set the voltage scale for now to maximum. And you can see there the individual traces with the red and the green lines. If we turn the DRL gain setting down to its minimum, you will see we get a very strong 50 Hz signal that's picking up there. If I touch some of the grounded metal to discharge the static on my body, you will see initially the individual signals go into saturation, and then they come down, and they're much smaller because we're shunting out much of the 50 Hz through my ground connection. If I then remove the hand from that, you will see that after a few seconds it stabilizes, but we have a 50 Hz signal there of around ±2 volts. As I begin to increase the gain, you will see very quickly the effect of the DRL circuit to reduce that 50 Hz signal. Let me just turn that down again to minimum and back up again. And you will see the 50 Hz reduces. Let's just change the voltage scale. The red trace from channel A has now disappeared off the screen due to some DC offset because we've taken the filters out. But we should be able to increase this. In some circumstances, if the 50 Hz levels are particularly high, which is not the case in this room, then you will see above a certain amount, a certain setting on the DRL gain, then the 50 Hz signal on here will start to become distorted and will start to clip. That's too high, so you need to run it such that you've got the maximum reduction in 50 Hz without starting to see distortion. Okay, if we now click the differential signal back in, which will be the white line, and in fact you can see there some of the distortion on the 50 Hz, so we'll just back that off a little bit. We'll take out the individual signals and we'll put the filters back in. We'll then reset the time base to 0.5 seconds and reduce the voltage scale down to 50 millivolts full scale. And you can see there the trace shown very clearly. If I choose a different pair of sensors, so I was using sensors 2 and 5, and then using sensors 3 and 5, and we'll just wait for that to settle a little bit. You can see a similar trace. Let's try sensors 3 and 4. And sensors 2 and 4. But I think in this particular situation we're probably getting the cleanest signal from sensors 2 and 5, so that's the ones we would use. Let's just have a look at sensors 1 and 6. You can see a smaller size there because we don't have expanded electrode size. But you can still see the signal. So let's go back to 2 and 5, and those are the ones that we would use.